Well, I think we'll get started right away, as there's always so much delay. Hello and welcome, all of you, to my talk on how to design a decent user interface.
Please speak closer to the microphone, we don't hear you.
Okay, thanks. Better? This way? Yeah. Sorry. Okay.
Ja, viel besser.
Okay, then now we'll get started. And I welcome you again on how to design a decent user interface. I study computer science, and I'm currently specializing in the field of usability, interaction design, human-computer interaction, whatever you want to call it. And I want you to switch your perspective, which I assume is the one of a developer. So this is who of you is a developer / programmer? Like, you know, well, yeah, that's kind of what I expected. So, first the manual. To quickly find out whether this is a good example or a bad example, I mark them with a plus or a minus. And I want to point out that the applications that I choose as examples, they're not particularly worse than other applications. They just happen to be around when I look for examples. So could have been anyone. This is the table of contents. We will look at reasons for poor user interfaces, why you should walk the extra mile and do it right, how you can do it right, some tips, and we will look at common factors for users as human beings and for users as individuals, and we'll take a dive into user-centered design, do a short sum up, and some hints on when I hope that I'll make you curious how you can find out more. But a quick detour, just to make sure that we are talking about the same thing here. What is a poor UI anyway? So users, usually they have a task, something that they want to accomplish with the computer or with your application, and they want to get it done. And each time your application they can't figure out what to do, where to find that option, they are disturbed and it breaks their workflow. They can't think about what they actually want to do. And that's basically a poor user interface. Sorry. And I want to give you one example, which has several factors. This is a searching interface for a library. It's web-based. And actually the library that is from is very, very good. Just the search interface is bad. You have to figure out for the machine what is the author of the book, what is the title, abbreviations, what is a publishing house. So you have to make you have to distinguish for the machine when you enter the data. And better would be like Amazon does. You can just dump anything that comes into your mind about the special book. Whatever it is, you just dump it, and usually they find something. So the machine relieves me of this workload. I don't have to think for it. The second thing that is flawed with this example is that it has the wrong flow. The first time I used it, I entered all that data, and I was looking for a button, because this is the end of the page. And I was like, hey, where's the search button? It's web-based, so I assumed this was the navigation, but it's not. Here it's where it says search. And I am from a Western cultural background. This is a cultural thing. And for us, we write from left to right, from top to bottom. And if it goes from right to left, this is not the natural flow for our culture. And this is something you can easily avoid if you know about it. And the third thing and last thing that is flawed with the example is that they use jargon. In the search parameters that you can specify, it says here Titel, Stichworte, and Schlagworte. If you are an English speaker and you'd ask me to translate Stichworte and Schlagworte, I'd say keyword for both of them. So I have basically no idea where's the difference. I guess in the back of my mind, I think it's a librarian term, and there is actually a difference for a librarian. So in this example, there jargon slipped in from the library, from the client, who gave the Auftrag.
Contract.
Thanks. Who gave the contract for this search interface? Jargon is always bad, as the only jargon that is okay in an application or any environment. A lot of what I'm saying today is applicable to other things, not only user interfaces. The only jargon that is okay is the jargon that makes sense to the user, which is usually from the so-called task domain. So if it's video editing, it's okay for you to use highly sophisticated, if it's for video editing experts, to use jargon from that area. But it's not okay to let slip in things from your area. So this is actually quite seldom that it's jargon from the client. What is really, really usual is that it's computer jargon. Things like UTF-8 suddenly popping up, but to most average users doesn't say anything. Things like that. And I'll come to it again later. We should avoid to let our computer jargon slip in, and the client's jargon as well, as it happened here. So now we get to the actual part, and we'll first look at submarines. I mean, you're developers, you might know some of them. There are many bad applications and user interfaces out there, and I guess it's not because developers around the world get up in the morning and say, make an oath to themselves, today I will design an application with a user interface so crappy, no one, not even I, will be able to operate it. Is it the Nord? More like it. So, first one to go is lack of awareness. There's a huge gap in computer experience from those who use applications and those who program it, which is us. And we often assume and use terms that don't make sense to others around our little bubble of computer perfect world. And it's also the case that developers often think they know what users want, because when they design the UI, for a minute they slap on their user's head and they try to think like the user. I think most people do that effort, but it doesn't work out because we are far from average users. We are usually people who want to configure like everything. Normal people don't. Things like that, they're a huge difference, and we need to be aware of them. If we can only keep that in mind, this is already an improvement. And this is worse because with each project you're in, this is not solely for computers. You develop an inside perspective. You are inside and you think about it all the time, and for 3 weeks now your brain is digesting that. And with that inside perspective, it is very hard to take a step back and look at your application with an outsider's eye. And my message is, you can't do it. You really need someone from the outside to do it. Second one, this is closely related to the first one, is that there's hardly any training. In universities and I think companies as well, there are only few courses. So I mean, where's the awareness to come from if nobody teaches it? That's why the one who has to program the user interface is often the one who ends up designing it. But designing a UI and programming it are different tasks. You may be a goddess in Qt, can program everything, but that doesn't mean you have a notion about how humans tick, how users tick, how to do it right. And yeah, you need different people, different expertise to do both things. Oh yeah, that's a nice one. We as computer people tend to like or prefer deterministic things, like numbers and facts, and I can run a benchmark and then I can say algorithm A is faster than algorithm B. But people are fuzzy. We are not that easily put into categories, and we differ. And it's less clear often, and it's also about trade-offs. So if you improve one thing, for example, you make it easier for the expert, then you make it harder for the beginner sometimes. Or if you increase the font to make it better for people that are hard of sight, who can't who have bad sight, yeah, then you can't get as much on the screen as before. So it's about trade-offs, and we tend not to like that. Yeah, pizza man reality kicks in when it's about time and money. There's too few, and usability is seldomly a priority. So this is what we're gonna do in the end if there's time and money, and there never is. And it wouldn't be, I mean, in the end it's too late. I'll come to it later. So, last thing, even if you know better, sometimes the client or management or marketing comes to you and says, you know, we want the button blinking. More bells and whistles. And you know exactly this will worsen the UI, but there's nothing you can do about it. And that's the saddest part. These are some of the reasons. Some of them are more valid than others. I think most of them you experienced at one point or the other. And I want to give you some incentives on why it's worth to do it right. The thing is, more and more people use computers that don't know anything about them, how they work internally. And while we might think we have already reached the peak, I think we didn't. This number will still increase. And that's okay. They don't even want to know about it. They have other things to do with the computer. And for them, the computer is only a tool. They use it to get things done. And I'm afraid for many of us it's also a hobby. You like to configure. You secretly enjoy configuring MPlayer after the Debian updates for 6 hours. And you're proud when you've reached it, when you succeeded. And
No.
You're not proud when you succeeded? So, yeah, I hope you get the point. Other people are not like us. And you have to put yourself into the user's place. Many of you are probably into open source software. You actually see the source code. An average user never sees the source code. The UI is the application. The judgment of the application is greatly based on the UI. And they never know that you've got like the cleanest code base in history and that your algorithm is so efficient and clever and you want to pat yourself on the back all the time for it. They'll never know. It's sad but true. And as we progress, as the IT branch, technology doesn't make that much of a difference anymore. Processors are fast enough and there's enough RAM, and for example, efficiency with that resources isn't as important as it was. So other distinctions become more important, and one of these distinctions is usability. And as people or many projects neglected, that's your chance to stand out of the crowd. I mean, I think it would be kind of cool if the open source software would become famous for being the best usable software ever. So we can do it. Yeah, that wraps it up. And we're now, hope I incented you enough, so that you now want to do it right. You want to do it right. I hope. And users have one thing in common. They are humans, and humans have common frailties, common limitations. And there are still applications that just ignore that. And if we can take that into account, then we will already achieve a big improvement. That's like half of the way. And I want to look at those human factors. First block is timing. There are certain time intervals that are common to every human, and one of them is the perception of cause and effect. This is 100 milliseconds. It's like 1/10 of a second. And this is what makes us, if we do A and B doesn't happen within 100 milliseconds, we are likely not to make a connection. If something else happens, which is completely unrelated, like the blue screen of death, we will make the connection. Ah, that's the evil button, last time I pressed it. And then there doesn't need to be a real connection. We want to create sense in anything and make a connection. And this is how we do it, basically, these 100 milliseconds. That means for everything that can possibly last longer than 100 milliseconds, you should react in some way, like display a busy cursor if you think it's not going to last long, the waiting time, or a progress bar. This sounds basic, but there are still applications that don't do it. And if you just don't do it, then people, they will make random connections, or random clicking, like nothing happens. I will do it again and again and again and again. And then when it finally happens, it's like 1,000 windows or something like it. Yeah, don't do it. And keep in mind that your system is probably faster than the one that the user is using. So next time interval is 1 second. This is the minimum reaction time a human needs to get that something happened or did not happen, something unexpected. So this means if you don't display the busy cursor or the progress bar, this is the maximum time you have until the random clicking kicks in. But still, please don't think, I've got 1 second. No, you've only got 100 milliseconds. And if you can, don't require users to react within a given time. Or it will always be too long or too short, depending. If you're waiting for something that needs to count down until it starts, it's and the other way around, if you need to be in time, then you look the other way, then it took you a second that you have to do something. It's always wrong. If you can avoid requiring user reactions within a time frame, avoid it. And this is an example from Toast 70 Dynamo. It's a CD burning application. And it says, your disk is ready and verification will start automatically in a few seconds. First thing, hey, this is a computer, it's deterministic. A few seconds, how long is a few seconds? A few seconds is about 10 seconds, which is way too short. I always miss that frame. A precise number or a countdown would have been nice. But still it's too short. I always miss that. And 10 seconds is the last time matter. This is our typical attention span. In this room it might be a little bit shorter due to multitasking, but normally it's about 10 seconds, which means if you break things into small parts, like a wizard or a dialog screen with varies, which is basically a wizard, then every part should take approximately 10 seconds, because this is the time we can concentrate fairly well. And it helps to keep users focused. One thing very important for developers is we are mostly focused on performance. The funny thing is, for humans, performance is not as important as so-called responsiveness. So the speed that we perceive from the computer with how fast an application reacts to us, to our input, to anything, it doesn't mean that the processing needs to be done. I mean, we're not wizards. But how fast the system says, yeah, I got your input and I'm doing something. That is actually more important than that you process it very fast. And so be responsive to your user. Tell them, yeah, I got it. And that is more important than being actually fast. There are some ways to increase performance, responsiveness. For example, if you queue processing internally, then prefer those processes that will be visible as output to the user as a change. If you, for example, do a text editor, then the most important thing is to show all the characters. Have you ever used SSH to write a text and it lagged and you typed and like 5 seconds later there your character appeared? It sucks. So, I mean, in SSH there's nothing you can do, but sometimes you can do, and then you should. Or pre-process likely events. I mean, if there's like 3 things users can do, and A is always, in 90% of the cases, the one they want, and you can pre-process this and you're idle, oh, well, pre-process this, and it will be like, woo, magic to the user. So next factor that is limited in humans is memory. Our short-term memory is very, very limited, and 7 plus minus 2 items, which doesn't sound that few, but it is because you don't have it for yourself. Your application is not the only one who needs some memory. So recognition, I've seen this one, and I recognize it, is better than recall, which is to, yeah, that name, no, I don't know anymore. We're better to spot something that we've already seen than to make it out. And as an example, could you describe the way you took this morning, you got here in some way, could you describe it to a stranger so that she would find her way home? I guess not. My guess would be that you miss some street, some turn, some wrong side, but it's very likely that you yourself will find your way home in the evening because you've been there, you've already walked that street. And there are lots of visual cues in the surrounding and the environment that let you get it. That's basically a recognition. And that we are better at recognizing is also the reason why graphical interfaces are more successful than the command line. Command line is very efficient, but it has a huge learning curve. I once made this suicidal step to switch from Windows to BSD, and I mean, maybe you can imagine me, the prompt like blinking, and I was like, yeah, no. I mean, what do I type? And in a graphic user interface, you can always like, move the mouse around, see what happens. And with the command line, that's not that easy. This is an example for recognition. This is a Keynote, a slide preparing program, which is running in the background. And when you open a slide set that has already been opened, then it gets you to the page you were on, the slide you were on when you last exited the program. And that helps with the, where was I effect. And there are also some text editors that do it. And it helps us get back to the way we left off. Oops, I'm sorry. So, yeah. And of course, if we want people to recognize something, then it also must be visible. So now I'm talking about graphical user interfaces. And the general rule is that every option there is should be accessible through the menus. But apart from that, kind of here's trade-off land again, because the menu, it takes time to show it. So you want to enable users to use with one click the option that they want. That's how the toolbar got into place. And sometimes it's very tempting to just put everything, to duplicate the menu entries into the toolbar. Because, hey, and then it's faster. They can just, one click and it's all there. Actually, it's not faster because humans take time to make a choice. So if there are many items, it takes us a long time to distinguish which one is the one that I want, which one is important to me. So if you clutter the screen with lots of things, yeah, that's a bad thing. And the rule of thumb is that you should only put the most frequently used items into a toolbar or something like that. And then there's also a technique called progressive disclosure, which you can also employ successfully. I've got an example. This is from VLC, media player or video player. And as soon as you check the load subtitles file, before that it's grayed out. The settings become available, and the settings is so this is what progressive disclosure is. There are more options available, but you don't show them until they are needed. as other buttons are like detailed, more visual information. Next human factor, attention. Ours is limited. Although we often claim we are multitasking, we are not even the women, and there's only one task that can have our conscious attention. And if you have to split that attention between two tasks that would need conscious attention, then our performance suffers. But the brain is very clever. We've got a workaround, which is that we can form habits. The brain can automate. Like, think of when you learn to drive. That's a huge overload. You have to do all those things at the same time, like watch and connect and the gears. But now you can do it with no effort. It's, well, you can listen to music, you can talk to somebody. So an automated task doesn't need our attention. That's how we get along in life. But we can't automate things that involve problem solving or that are creative tasks. Writing a text or editing an image, programming, all those are creative tasks on which we have to focus. The task of our user that uses our application is the one thing that should have the attention, and it shouldn't have to share it with figuring out how the application works. And one thing to achieve that, users should be able to operate your application automated. And one thing to achieve this is consistency. It basically means that you're predictable to the user. If two things are the same, like from a user's point of view, they needn't be the same technically. Like, let's say an MP3 file and a stream. For a user, they might be two sources for something to listen. For you, they might be technically very different, but as long as they are the same concept for the user, offer the same functionality as much as possible. And you can think of this like the principle of least surprise. And I like to illustrate it with an example for inconsistency. This is about inconsistent progress feedback. This is again the CD burning application, Toasty Time. Burning a CD has 3 phases, which is filling the cache, writing the CD, and finishing the CD. So this is the progress area for filling the cache. It gives the progress here in %, and there's no progress bar. This is only the setup for the next step. Then writing the CD has the progress bar. It doesn't have %, so this is empty. And it has the time left, counting down. The one thing it does good, it also shows the progress in the docs. So this is actually, they got that one really well. And the last phase is finishing, and there you have no feedback at all. We don't have %. We don't have time, because that is from writing the CD. We don't have a progress bar, because this is also from writing the CD. And this is more than half a minute. This is a long, long time, without any feedback. So, to me, these 3 are pretty similar. But I've got 3 different ways to show progress. Well, 2, because one is not showing progress, which is not really. You might wonder how can this be? How does things like that slip in? Some speculations some reasons I could think of is they are technically very different. Might be. I don't know about burning a CD-ROM, so maybe they didn't see that from a user's point of view. This is completely the same thing. It's always about progress. It might be a lack of communication or supervising management. Maybe there are 3 developers, each one got a part, and Alice, Bob, and Eve, they just all, did it their way, and then in the end, nobody cared to make it right. Maybe no one was aware of it. So consistency as a whole is a very wide and very blurry concept. That's why I'd like to concentrate on one part of it, which is text consistency. It's just not that blurry. And when you can improve that, it's already a big step. The first advice would be to avoid ambiguity. Language is full of ambiguity, and just take, if I only say cock, what are you thinking of? Really?
What else?
Of course, man, what else?
Well, give us the other thing.
Making me blush over here. No. So, in the real world, there is lots and lots of context. So if I say, last week I went to a farm and there I saw the biggest cock I've ever seen. You know that I'm talking about the animal. But if I say, well, Sven, you have to pay attention, now I'm giving it to you. Last week I saw this porno movie and in it I saw the biggest cock I've ever seen. Then you know it's the other thing. The one you all thought of, even you.
Animal porno?
That's illegal, I will never confess to that. So in everyday life there's context for us to make sense. In applications, much text is isolated words. Menu comments essentially are isolated words. There's no context at all, so you get confused, or users get confused very easily. And wording, that's what it called, picking out the word. That's a very difficult task. One example, let's say we're in a 3D rendering application and you can have one model and different camera views on it. And you've got a command, view settings. So what is this command gonna do? Will it show you the settings of one of the views? Or will it let you view some general settings? Like, this is a situation to avoid, and like choosing a different name for the camera views, like perspective or something like that. The worst case would be that both things happen in different places of the application. So that one time it shows you general settings, one time it shows you the settings of the user. That's like a no. Second thing, call X, always X. So for each object, concept, action that you do in your application, choose a name and stick to it. As an example, my father got the login data for his internet connection from I think it's the biggest T-Com, the biggest provider in Germany. And we needed his login data to configure his email account. And in the documents, he got a passphrase. And the login screen asked for a password. And he looked at me and he said, you know, there it already begins. This passphrase and password, is that the same? I mean, sure, for us it's obvious, but average users tend to think that there are really differences in meaning when we use different words, and that's why we should avoid it. We pick one and stick to it. And this is a really hard task. Even if you're alone, it's hard, but when there are several developers, it's nearly impossible. And your best bet is to introduce an application lexicon. In it, you write down, you keep a record of all the terms that you agreed on. For this dialog window is called XY, and this one is ZA, and we will call that little blinking object always A. And assign someone to make sure that these terms are used consistently. And of course, this task is much easier if messages to the user aren't scattered around the application, but use a central message file. And then it's easier to make sure that the terms are used consistently. And get a technical writer, because again, writing, wording, keeping terms consistent, that's again a task of its own. And programmers aren't always very good writers, I'm sorry to say. And this is an example of text inconsistency. Now, this is from NeoOffice, which is an open office for the Mac, I think. And I wanted to insert a spreadsheet, and I wanted to try out the little icons on the left. And the first one, the tooltips told me insert, and that's what I wanted. I wanted to insert an object, yay! And then I clicked on it, and then it says insert table, and I was like, no, I don't want to insert a table. So why would you cut off a tooltip? That would have been easy. Don't give less information in the tooltip. So, oh, sorry, that was a bit rushed. So we leave attention and consistency, and we go on to errors. Humans make mistakes. Even the Romans, errare humanum est. Keep that in mind. It would not change just because your application isn't apt to deal with user errors. So don't just ignore this. Prevent errors if you can. Don't let users invoke commands that they can't use for this object. I've learned 2 days ago that, what was it, Inkscape, I think, doesn't do it. It doesn't depend on what you selected. All options are available, and this is a pain in the ass, even because you don't get the result. You need to know what you can do right now. So gray out menu items that aren't available and things like that. Also provide a sensible default. Don't ask users to take choices that they don't know the adequate answer to. In a text editor, if you ask in the save dialog, yeah, do you want ASCII or UTF-8? And to most people, this will be, one of them. So set a default, which is the right thing in most of the cases. And you will, relieve users of this burden.
Which one would it be in this case?
Yeah, that's hard to say. I guess it depends on the context. No general answer, sorry. And don't let users enter freeform text. If you could be more specific. One example. The top one is what I use in my home-brewed blogging software, because I don't depend on the format, it's just I want to keep it the same, and it's very fast. The top one is faster. I would never use the top one if I really needed the format, and for people other than me. And the top one, I know the only user, and that's me, I know I can do it. And the bottom one, I make sure it's the right thing. So if you need a specific format for anything, and dates are a great example, then use lists, and they can't skip a digit, which would have been important or something like that. Of course, this takes a little longer, but you can't make an error here, and that's, in most cases, preferable. The second thing, helpful error messages. We can all learn a lot here. It's not like users commit errors just to, bug your application. It's because they really didn't know. And there's no need to bark at them. At least be polite. They are probably upset right now because they got an error for something that they want to do. If you can, if there's a very common error, and and there's a common source for the error, then provide a hint to solve the problem. An example would be on login screens, there is often, if the password didn't match, that you get a little hint as caps lock activated, and yeah, sometimes that's the reason. And the reminder is cool to look at it. It's simple. There are things where you can be more helpful than that. Really, guys, error codes. Error codes are for debugging, and only for debugging. This is when you've done debugging, and you get them out. Users never ever see it.
I strongly disagree on that. An error code provides you the ability to search in the source code what's happening.
Yeah.
Also Google for it, which is nice.
Okay.
If it's a unique error, that's correct. Yes.
I specify, don't make errors. Don't let errors happen. No. Oh, that's hard. Sven gives this, I'm repeating it for the mic. Not for the video? Oh, well, okay, then not.
There should be a details button. should be a details button so you can see.
Ah, that's a good one. So, Sven Gucke said that error codes are actually very good for Googling, which I agree on because they're normally more specific. And this guy put out that there should be a details button. So this is an excellent example for progressive disclosure in this case. So very well. You?
Yeah, I wanted to say, what do you do when the user calls you and then says there's an error? The first thing you ask is which error code or read me the exception or something like that.
Yeah,
And
that's a good one too.
With the details button.
Yeah, okay. So this is essentially the details button for the error code would be the same for this one. So, yeah, geek names for errors. This is the example for it. This is again NeoOffice. It says here, so this is an example where you could get rid of the error code. It says error 503. And I was like, yeah, well, that's interesting, error 503. This is division by 0. And you could give that error a more telling name, like div by 0, which would have been 6 letters instead of 7 letters, error, colon, 503. So sometimes you can give a meaningful, a telling name to an error code, and then you should do. Third one, preserve the user's work. Never lose data. If you've ever written an email and then you wanted to send it and then something happened, crashed, connection lost, whatever, and you had to do it again, this is so annoying because you feel like you did that and you don't want to do it again. So never lose data. Provide an undo and a redo functionality for everything and make sure that it works because users will heavily rely on that. And if then suddenly it doesn't work, this is horrible. And users' work is also data that is entered in a dialogue. For example, the Amazon. I wanted to get a book, and I entered my address, and then my bank account, and then I decided to change the address. I wanted to deliver to a different address, so I went back to change the address, and I had to fill in my bank account again. I mean, they changed that, I know. No?
I don't think they changed it, but I always thought it was for security reasons.
Yeah, I mean, and now they changed it. Now they keep the bank account in mind, so I think it must have been something else. Well, maybe it's security. I found it highly annoying because I had done that. I mean, they can remember a book I bought 5 years ago and recommend me others from the same author, but they can't keep in mind my bank account. So now we're done with the users as humans part. And if we take the common human factors into account, then we're already 1/2 of the way we went. Yeah, but still we are all individuals. I'm not. And we vary greatly in our experience with computers, in our experience in the task domain, in our age, gender. We have different cultural backgrounds. Some of us have disabilities. These are all ways in which we differ. And what is right for one user can be completely wrong for another one. And to get the flow of the interaction right and the interface and bottom layout, we need to define right for whom. Who is our user actually here? So that's what we're now going to look at it. And it's also a quick introduction to user-centered design. Who's the user? Central question, first central question. Sometimes you know who the user is going to be because it's a contract job. So a client gave you a job to do, and well, then you know it. But in other cases, you have to choose to target users yourself. There are a variety of applications that just fail to do that. They think, hey, for everybody, our application is for everybody. But have you ever tried to please everyone? It's impossible. If you try to please everybody, you'll just make everybody unhappy. So it's a very hard thing to do, to please everybody. And the most grave distinction here is experience in the task domain and possibly experience with computers. So That's where the trade-offs lay. So you should define who your user group is going to be. And then when you've done that, the second interesting question is, what's the task actually about? What are the things that my target users want to do with my application? What or have to do? Sometimes, I mean, a lot of people are forced to use Windows in their working place, things like that. What are frequent tasks? What are rare tasks? If you find out about that, then you can limit feature reaches. It's like, I think we should have that extra button which says, and then you can say, no, we find out that our users like never do that. And then you can just leave the button off. Things like that. Also important, will your users, your target group receive training? For example, it's for a big banking company, and they all will learn how to operate it in a 2-hour course. Then you have a different setting than if it's a public terminal and people will encounter it, by accidentally. Same thing applies for how often will they use it. Will they only use it once? If they only use it once, then it must be extremely easy to learn. Them should be able to operate it immediately. But it can take a little longer. It may be cumbersome, as long as it's obvious how it's operated. For a one-time use application, that would be okay. If they use it every few weeks, don't rely on people remembering how they did it the last time. This still means it has to be very, very easy to learn. Very obvious what is to do. Cumbersome, well, should be, if they use it daily, then it needs to be efficient. It might be okay if they have to learn a little more, as long as once they learn it, they can operate it very quickly. This is all about trade-offs. And for that, you need to know in what setting your application is going to be used. Also, maybe your application is only one in a chain of applications, and then it would be wise for you to offer export and import possibilities for the applications that are likely to interact with your one. Some ways to find out about the tasks the users want to do is site visits. Go there and observe the user in his natural environment. Like here, take notes. A questionnaire is very popular because you can do it in masses on the web. It's essentially asking about what applications that are similar to ours did you like or dislike, or what do you do? So some basic questions. Interview is mainly the same, but it's from face to face, so the numbers are lower. But if you didn't understand something, then you can ask and make things more clear. And while you do that, think in terms of what will the user be able to do with my application. Don't think about, how I'm going to implement that. So, this is not what it's about in this phase. And our two main questions, who's the user and what's the task, that's the beginning of user-centered design, which is a design approach. So but comparable to Rupes, which is also a design approach to developing software. And I've copied the definition from Wikipedia because I doubt I could do it better, so I'm going to read it out. User-centered design tries to optimize the user interface around how people can, want, or need to work, rather than forcing the users to change how they work to accommodate the system or function. This is something that we're likely to do, to concentrate on the needs of the machine, because we're very close to it. We know it very well. Well, it's not the way it should be. And the main idea of user-centered design is to include users during the whole development process. And after identifying the user and the task, you enter an iterative process, which is you design the application, you implement a prototype. In the beginning, these are very simple ones. I'll come to it. And you test the prototype and analyze the results. And you test it with the user. Then you go back to one until you've got the final product. So, for the graphic people, so you design, you implement a prototype, or in the end, of course, the last prototype is the final application. and you analyze it in a user test. And the importance of early testing cannot be overestimated. Usually this takes place in something like better, and then it's about putting the button here or here. But that's not the point. In my view, good interaction is like security. It's not something that is an add-on that you can add in the end in moving some buttons around. It's an underlying concept. You need to get the interaction right in the beginning. If you don't do that, then just polishing in the end won't do much good. And the earlier you test, then the easier you can correct misconceptions that you've had. And what is also important, we tend to have, when we think we've got a great idea, it's hard to let that idea go. So that was a brilliant idea, and if we put 200 hours of programming into it and then find out that nobody needs it or nobody gets the concept, then it's hard to give that up. But if you find out in the beginning that your idea wasn't as brilliant as you thought, then that's easier. And a prototype needn't be software. There are also paper prototypes, which are drawings of the screens, post-it prototypes, which is the same as a paper prototype with an add-on. Post-its, you all know it, and you can simulate menus and things like that. Or Photoshop and GIMP mockups, which are more realistic, but they don't have function. Or you can also have low-fidelity software prototypes. For example, Flash prototypes. You can simulate very easily the whole interaction with them without any functionality in the background. And I've brought them. I brought you a paper prototype. So you see the first screen in big, and it's for a fictive tool that lets you physically find a certain book in a large bookstore. Because I like Amazon because I always find the books I want to find in large bookstores. I always get lost and always have to ask someone. So you hold it like this, of course. And with that you can already do a test, and you can ask like, if you had this tool and you wanted to find Secret and Lies by Bruce Schneier, what would you click on? And then the user would choose one, and you would file through your papers and just get the next one. Something like a very simple, very basic. And now, my paper prototype, post-it prototype. So it's really only a collection of paper, and that's easy to do and easy to dispose. If you see this is bullshit what you've done, you can just, that's easier than making this with hours of programming. Second prototype example is a Flash prototype. This is also fictive, and it's a handheld device to coordinate units in a mass event like medic, police, fireman, security. And here it is. So it would be the size of a PDA. And here you can already interact with it. Would have a touch screen. You can order some units. So that's a very simple implementation. And the more iterations you can break your development into, the better it is. And with each iteration you do, the application gets more and more concrete and more detailed. Well, we are nearly through. So now we have the summary left, which is that users are often forced by applications to concentrate on the application rather than their task, what they actually want to do. And if you take common human limitations into account, then we already achieve a big improvement. And apart from that, many developers have the misconception that they know what users want, although they really don't, unless they ask their users. Of course, you have to know who are my users and what is their task to ask them. asking is basically testing. Yeah, the more often and the earlier you ask or test, the better it is. And if you get it right in the beginning, it's with everything in life. If you get it right in the beginning, you save yourself a lot of trouble in the end. And you get a superior product in usability terms. I hope you're curious now. Here's some starters. So the first one, the design of everyday things by Donald Norman. It's like lays the groundwork. It's rather old, from the 1980s, and it's not about software or user interfaces. It's about usability issues in everyday life. It makes you really aware of many things that go wrong in real life. It's a little repetitive sometimes, but still, to get it into the right state of mind for usability work, I highly recommend it. It's very good. The second one is for hands-on people. If you want to do it right now and you want to know some rules, how to do things, this is the one for you. GUI Bloopers by Jeff Johnson. It's hands-on. The first chapter is about the theoretical groundwork, and then he goes into different aspects of software development, and it's I think it's really applicable right now. The last one is Don't Make Me Think by Steve Crook. This one is based on focusing on websites, but I think it's applicable to more than websites, and it has very good chapters in the end about user testing, and it's hilarious to read. I really recommend it. It's a little expensive from my point of view. So then, when I first did this presentation, it was 2 hours long, so I had to get rid of lots of things. In the paper accompanying this talk, you'll find additional information, which is links and a passage on how to run a user test properly. So you can get the information from the paper. That's it. Thank you.